Hello everyone. In this video, we are going to troubleshoot the synthesis of amidine derivatives. This is the general structure of amidine, where you can see two nitrogen atoms are there. This is very important precursor for the synthesizing the pyrimidine derivatives, but most of them are very expensive. For example, this 2,2-difluoropropane propanimidamide is very expensive. Therefore, to understand the synthesis of these amidine is very important. Recently, in 2024, Vividion Therapeutics published a patent in which they have shown the various pyrimidine derivatives as WRN inhibitor for the treatment of cancers. You can see what they have synthesized. So these are all those are the different derivatives of pyrimidine. You can see, and the synthesis of those pyrimidine is required the reactions of amidine with this diethyl malonate ester derivatives in the presence of sodium methoxide and ethanol at 90 degrees Celsius. But we are going to discuss the challenges we observe in the synthesis of amidine. So this is the screenshot from this patent. And example 87 from this patent, this is the best WRN inhibitor. We are going to understand the key step involved in the synthesis of this WRN inhibitor is the synthesis of this amidine. And the procedure which they have shown in this patent is like this: ammonium chloride, almost 5 equivalent, taken in toluene, treated with triethyl aluminum in hexane solution at 0 degrees Celsius until no evolution of gas was observed. This gas is coming from this by the reactions of aluminium, trimethyl aluminium with the ammonium chloride, and which evolve the methane gas. When there is no evolution of gas, you have to add this ester and heat this reaction at 80 degrees Celsius. After cooling down at 0 degrees Celsius, add methanol and then stir at 25 degrees Celsius for 1 hour. And then you get a lot of solid precipitate. But this precipitate is not usual compound. So you have to remove this solid precipitate and wash it with methanol and this filtrate, which you get this filtrate concentrate and you get the your product as a white solid in 89% yield. But actually, this 89% yield is because of the amidine is highly contaminated with ammonium chloride salt. Since you are using 5 equivalent of ammonium chloride salt, and after that you are washing with methanol, so whatever unreacted ammonium chloride left over, it comes in the filtrate. And then after concentrating, you are getting amidine contaminated with ammonium chloride salt. So, what is the problem if you have ammonium chloride salt? Let's understand what is the next step. So next step is the reaction of amidine with this diethyl malonate derivatives, which leads to the formation of pyrimidine derivatives. And once you have this ring, then remaining steps are easy, because if you go to look this molecule, then you have to put here phenol, and then this you have to put just amine by amide coupling reactions. So that's why, according to me, to understand the synthesis of amidine is very crucial. So now, as we said that this amidine is contaminated with ammonium chloride. So what is going to happen in this step? Then this ammonium chloride will react with this, and you will not observe the formation of this ring. What you will get the amine will react at this position, because this is highly reactive position, and you get this kind of byproduct. So what is the solution? How we can get rid from the excess of ammonium chloride solution? So let's move to the next step. So here I put reported procedure and then observation. In 1H NMR, we can observe big ammonium chloride signals in the aromatic regions. Now the question comes, how to get rid of excess of ammonium chloride salt? So the refined procedure is that you take this white solid which you obtain after following this procedure. Please remember that after following this procedure, whatever white solid you obtain, that is contaminated with the ammonium chloride. So we are going to understand how to get rid of from those ammonium chloride salt. So take that solid, dissolve in 10% methanol in DCM, and you will see that desired product will solubilize in this 10% methanol DCM, but ammonium chloride salt was insoluble, or we can say that sparingly soluble. So the process was repeated several times until no traces of DP left in insoluble salt. So you can whatever insoluble salt is there, then you again treat with this 10% and collect this organic layer. And after all filtrates were combined and concentrated, which afforded semi-solid as a desired product. And the actual yield is around 28%, which is free from unwanted salts. According to this reported procedure, they obtained this amidine. But after purifying this compound, as by this refined procedure, we observe that this product is actually obtained as a HCl salt. So hence we should remember that this reaction gives you amidine in the form of HCl salt, and the excess of ammonium salt which we were getting after this procedure, we removed by treating with 10% methanol DCN. And once you have this pure amidine, you can follow this procedure to get the cyclic desired product of pyrimidine rings. And after that, it is simple and easy to get to this target.